Welcome back, everyone. Today we're going to talk about solving equations with the distributive property. So, what's the distributive property? The distributive property tells us that A times B plus C is equal to AB plus AC. Or, in other words, when we multiply A to a sum, B plus C, that is in parentheses, we need to multiply A not only by B, but also by C as well. We need to distribute the A throughout B and also throughout C. A common mistake I see is students only multiplying by B, so ending up with A times B plus C, but that is not correct because the A needs to be distributed to both B and C as well. So let's do an example of solving for x. So we're going to use all the techniques we've previously used, but we're also going to use the distributive property to solve this one. So for example, how would we solve something like this? I'm going to start with using the distributive property to distribute the negative 5 into 3x and also into 8. So my next line will be 5 is equal to 12x, so just copying. And then minus 5 times 3x, that's going to be minus 15x. And then negative 5 times 8 is negative 40, so minus 40. In my next step, I'm going to collect like terms. So 12x minus 15x is negative 3x. So 5 is equal to negative 3x minus 40. Then my next step is I'm going to add 40 to both sides because I would like to get all the constant terms on one side, in this case the left, and all the non-constant terms, all the terms with x on the other side on the right, so that we can isolate for x in a little bit. So I'm going to get that 45 is equal to negative 3x. And then my very last step is to divide both sides by negative 3. And then we just get x is equal to 45 divided by negative 3. 45 divided by 3 is 15. And so if we're doing 45 divided by negative 3, that would be negative 15, because recall that when we multiply or divide a negative with a positive or vice versa, then we end up with a negative answer. So therefore, that's the answer. It's negative 15. And let's say you're skeptical, you're not sure if it's really negative 15. You can check that by plugging in negative 15 back into the original expression and solving, making sure you're solving using PEMDAS and reverse PEMDAS where applicable, and that should give you the correct solution. Okay, let's try a second example. How would we do example 2? So in example 2, there's actually two choices. We could use the distributive property and distribute the 1/2 into 6x minus 4, or we could just multiply both sides by 2. However, I want to point out that let's say we do that. Let's say we multiply both sides by 2 like this. We would have to distribute this 2 into both of the things here. And so either way, we're not going to escape using the distributive property, regardless of whether we apply it right away or whether we multiply both sides by 2, and therefore are able to cancel out the 1/2. Okay, so that's something important to keep in mind, is that either way, we're using the distributive property one way or another. All right, so let's just use it from the get-go then. 1/2 times 6x is equal to 6 over 2x. 1/2 times negative 4 is negative 4 over 2. And that is equal to negative 5x plus 1. I'm just copying here. Now I'm going to simplify some of the things on my left. I noticed that 6 over 2 is the same as 3, so 3x. And then negative 4 over 2, well, that's the same as just negative 2, is equal to negative 5x plus 1. Okay, now I need to get every term with x in it on the left and every term without on the right. So what I'm going to do is I'm going to add 2 to both sides. So these 2's cancel out, and we're just left with 3x equals negative 5x plus 3. And then I'm going to add 5x to both sides so that these cancel out, and I get 8x is equal to 3. And last but not least, I will divide both sides by 8. And if I do that, then these cancel out. And I'm left with x is equal to 3 over 8. And that is going to be my final answer for this one. All right, well, that's it for this one. Good work, everyone, and we'll see you for the next one.